Okay, here's an update to the new types of crystal batteries. I made a lot of discoveries, and hopefully this try to explain what I think I discovered. So what we have here is a piece of aluminum foil here and a piece of conductive materials that I painted. You can find that in the website, conductive ink or conductive paint, and how to make them. But I've made my own, and no electrolyte in between there, so they're not stuck together. They're just two pieces of piece of paper and a piece of aluminum. And if we bring the reading, let's see, and let's take a reading on this, if we can see it. Let's see here. Can we see that? Yeah, pretty good, pretty good. So the black is a positive, and the silver is, which is the aluminum, a negative. Okay, so as we can see, we have a voltage, my bad. We have voltage, and that pretty stays them up. But what I found is doing this voltage, that this was electrostatic. So if I rubbed it, I actually got it to build electricity just by rubbing it. And I was like, wow. So I start fooling around with it, and remember, I was doing crystal batteries in the first place, so I made this other cell with a crystal battery on it. Now this right here is this piece right here laying over this penny. What it is the crystal powder, paint it and let it dry, and paint it and let dry, and then it forms crystals on the towel paper that I used. And then I can wet it with this little circle that I have here so water didn't go all over my paper. Then I put that against a penny for a collector, and then I use this more like a capacitor, okay, because it acts like a capacitor even though it gains charge. And I stuck it to one side of the penny and one side to the crystal battery, and which gives you a voltage. And when you wet that down, the voltage will go up. And I wetted it all earlier, so we already have a charge there. Okay. Again, if we take that and push that just a little bit, a little pressure, you see it tries to go up from where it's at. And again, if you rub it, it tries to go up from there. So it's electrostatic. And so by doing that, what I did is I made a bigger cell, okay, because these were just for demonstration. This right here was the bigger cell. Let's see. Do I have that upside down? I probably did. This is right here is the bigger cell. So what I've did is I made my battery, and as you see, it says 1.22. Now I call it now, even though I called it different, any electro from the battery in there on this, the battery, and my cell, which is an electrostatic cell, which gains atmosphere out from the atmosphere, connect them together, and it constantly stays at that voltage. Now what happened is that, let me see if I can get that in it. I'm going to press play, and I'm going to turn that on. As you can see, starting to come on, and it's playing. Okay, now even though I don't got headphones on here, that is actually playing. and you can see that the little battery indicator is 0, so it's almost depleted. And as you see, it's going down as it plays. Now this thing played about 3 minutes long the last time I tested. I haven't tested it again, but I just wanted to know that the voltage is going down. And I ran it and depleted it, and then what I did, let me go that down one more, is then I turned it off and my cell charged it back up. Okay, now it doesn't have much very power. This is barely making a volt. This little cell in here is barely making a volt. So let's turn it off, because okay, we down to 114. Let's turn it all the way off. So it's going off. Okay, so you can see, and then the voltage starts to climb. So I says that may be something. That's when I actually made this second cell right here, and I'm seeing wet cell, dry cell. One gains electricity from the atmosphere, which have an antenna on it, and this part right here, which will be my solid fuel cell, is that I'm going to treat it more like a crystal battery, and I'm going to wet it occasionally, let it dry out, wet it occasionally, watch the corrosion. But even though if that copper in here is the sacrifice anode or cathode, then you just replace it. So you could actually run copper and have these copper cells, punch them in like you do a slot machine, and it should run until it just depleted. It eats all the way up, and then you pull it out and you place another one in there. So I'm working with that, and it's working out pretty well, because like I said, I'm getting over a volt. It's charging the battery, so it has just enough volume to push that amount of voltage into it, even though it's no amps. Okay, so I don't know which way you can see that, if that's upside down or if that. I got a new camera, so I'm trying to get used to it. Again, this cell right here has been running well over 12 days, and as you see, it's starting to go up. Okay, let's see, let's get that out of the dark. Yep, we can see that pretty good. It's starting to go up, and it'll be at 20, and it'll go 22, and again this cell is going to keep doing that, and I'm going to keep discharging and charging it, discharging and discharging, and I'll let you know how it's doing on the next update. But that's pretty much it that I wanted you to see the names. Let's see if we can get the names up there. Okay, everything's backwards in this camera, so if it's backwards or frontwards, I don't know. I'm still used to this camera, but we got that on video, and we're up to 20, as you see. Still blinking back and forth, but it'll go to 22, and that means my cell, which is electrostatic cell made from your conductive ink and your aluminum foil with no electrolyte. Remember, this right here, where there's any kind of carbon, is a sort of crystal. It's a half crystal, I would call it, but you know, people will always get me on those technical things, but it's sort of like a crystal. So when you push pressure on there, you do get electricity from it. But this right here, even though it acts like a battery sometimes, because it's recharging by itself, it acts more like a recharging capacitor, because it charges up immediately and it drops almost immediately. So again, with the two, a stable battery and a capacitor put together, like in lithium batteries, and people didn't know that, you have a stable cell, which is right there. Stable cell, which means that left alone, they will recharge themselves. So hey, you guys, if you want to experiment, get back and let me know what your results were. And you know, if Robert Murray Smith is listening, try checking that out. I mean, we try all the experiments, but like I said, this experiment to charge things from the atmosphere is pretty impressive to me. Okay, thanks you guys.